All right, everybody. This is it's going to be new for me. I am actually going to be setting up a subnet on my local network here, and the reason for that is because I want to create a blockchain. So let me show you what I'm working with here.
360, 75 hours, 10 6.
Right, so I've got 4 old computers here that I've upgraded to newer systems, and these are kind of left over. 2 of them were mine. This was my wife's. This one was my system, and these 2 belong to friends of ours who they didn't need them anymore. So I've got these 4 systems, and I picked up an EBG15 here. I've got 1 monitor here and a couple keyboards, but I've got some extra monitors kicking around. And basically, each one of these systems is currently running Ubuntu Linux. Here comes Calvin's coming to help. So basically, what I'm going to do is we're going to set up a hyperledger, a Besu-based hyperledger on these systems. Okay, so I'm going to actually just go through this. I don't know, I'm figuring it out as I go along, and we're going to, hopefully you'll come along for the ride. But basically, what I'm going to have is each one is going to essentially be a separate node. And they will work together as a blockchain. And then from my main computer, which is in my office, which is a Windows machine, I'm going to SSH into these machines and do all the work, etc. And we're going to build a simple web interface that allows us to just do some stuff on that blockchain. And so it's going to be a private Ethereum-based network, and we'll go from there. What do you think, Calvin? Should the first thing that I mint on it be a picture of you? Yeah? All right, you know what? We'll get a photo of you sitting on top of the systems, and we'll mint that. Right, so just outside my office, I have this Netgear gigabit switch here, which is, connected up. I've got my main coming in, and then I've got stuff going to my theater room. I've got stuff going into my office, to the printer, et cetera, et cetera. So the first thing I have to do is this is connected up to my Asus router, which I'll show you right now. So that's where I have my Asus router, and as you can see, I've got the cables. So there's a couple hardwire cables that go, one to my wife's system and then to mine. One goes to security, and then that one there goes through the wall, across through this house, and goes downstairs to that switch. First thing we need to do is run a cable from this, probably along with this one, across here, and bring it over here into this VPN wired router. So I've got, I have another one of these flat cables. I've got a longer one. So that's what we're going to do first. And then we will get one of these computers hooked up to that switch, and we will get that switch set up as a completely separate subnet on my router, so that it's separate from my home system. So let's do that. Right, so got all the machines set up, and they are all connected now to the EBG15. So my internet comes in here from the Asus router, and then goes to each of the 3 machines. Currently have 1 machine up and running, or I've got all 3 up and running, but this one's connected up to the setup here. Now, what I had to do was I had to set up a WireGuard VPN. Okay. And so that had to be done. The other thing that needed to be done was to set up the wide area network and set it to automatic IP. Okay. And then what I did was, where was it? Is it under LAN? DHCP server. I set up a DHCP server with a starting address, an ending address, and a lease time. And then I'm just not going to put these in, but the three computers that are hooked up get static IPs based on their MAC address. Okay, so that is set up. Now, the other thing that needed to be done was the Windows machine had to be added as a VPN client in the setup. And I needed to add SSH server on each of the three machines so that I could use my Windows machine to SSH to these ones to control them. Now, doing that meant I had to install WireGuard on my Windows machine. Once I did that, I was able to SSH from my Windows to each of my Linux nodes. Okay. The only other thing that was left to do was to port forward on my router from upstairs to the... Oh no, I didn't bother doing that. Okay, so I have WireGuard running, and I'm just going to SSH here and do that. And as you can see, I am now connected up to one of the systems. So I can now, I'm on the Linux system as if I were, just on it, but I'm not. I'm on my Windows machine. So that's that. So that's one of the systems. There's the, just knocking things. There's the second system. So the first system is Matrix, the second system is Eddy, and let's do this. And the third system is LCARS. So there you go. So I am ready now to actually do the Besu installation. So we're going to, and we're also going to do a QBFT network setup. So basically, I have three nodes. So I've got node 1, which is my boot node and my validator. I have node 2 is just validator number 2, and node 3 is validator number 3. Now, normally you'd want to have 4 validators on a Besu blockchain setup for validation. In case one fails, you want to have at least a minimum of 3. Unfortunately, my my fourth computer that I had is kind of pooched, so it's got a hardware problem, so I couldn't install properly. Might look at that and see about fixing it, or finding an old laptop and maybe using that instead as the fourth node. But for now, that's what I've got. So I have 3 nodes. One of them's acting as a boot node and a validator, the other just validators. I have a Windows machine that I'm going to SSH to those via command line. I've got a WireGuard VPN tunnel, and we're, I guess, ready to go. So, yeah, let's see where we go from here with this. All right. Okay. So the first thing I got to do is I got to open 3 separate command windows here. just do this. And second one. So I need one for each of my 3 machines. Don't you know? So there we are. There's my 3 windows, and I'm just gonna just switch over to over to my main thing here. Clear screen and clear screen. All right. So I'm just going to set them up so that they are nodes 1, 2, and 3. So I got node 1. I'm going to have node 2 and node 3 like that. Excellent. All right. So let's get in here. Oops. There we are. And then okay, so it's not gonna, it doesn't transfer over. So okay, there we are. And 12 and password. Okay, so we are updated here. I got 13 updates on this machine already. Okay, I'll worry about that a little bit later. And this has 15 updates, and this one has no updates. It's like I just updated everything. I don't know what's going on. Anyway, all right. What in the wide world of sports? Oh, okay, I see what's doing there. All right, so we are now connected up to those. All right, we need to download and install Besu on each of these. So I'm going to do it with the first one over here, just because, you know, do one and go from there. So let's go. There we are. Oop, not fine. Let me get. Releases, download, 24.10.0/ Besu 24.10.0.tar.gz. Boom. All right, so we're just going to download that there, and I could probably just scream up to here and see if I can't just copy that, and I'm gonna paste it in here. Oh, it's not gonna paste it. Really? That's awesome. I want to do that. Well, that blows. Can't even copy and paste. All right, well, we'll do one. All right, so it got it. So here we go. So now tar, we're going to xzf Besu -24-10.0.tar.gz, and boom, that should do it. 24.10.0. Ooh, wrong slash. T/Besu. Alright, we've done that. Echo export path equals path : /opt/Besu/bin. And home tilde slash dot bash rc. Command. Oh, don't you just love that? Spelling errors. There's no exho. There's just echo. So let's try that one more time with the correct spelling. All right, there we go. Source tilde slash dot bash rc. All right, and then Besu version. Let's try it again. Okay, there we go. And that is installed, version 24.10, and it's in there, and it's tied to the OpenJDK Java 21. So I had to install OpenJDK on each of these machines as well. So I'm going to go ahead and just install this on the other two machines so you don't have to watch that again. Right, so as you can see on Matrix we have 24.10.0 installed. On Eddy we have it installed. And on LCARS we have it installed. So that's those done. So the only thing to do now before we can move on is to actually create the data directory. So I'm going to create those data directories right now. All right, let's hop over in here. Let's do it on the first one here. While we're at it, I know this is kind of boring to look at, isn't it? But you know, we'll do this. Let's do one. So sudo make mk dir. We'll use the trigger p and slash opt slash besu dash data. Done. And that's it. And I'll just do the others now. Right, so now we have to create a QBFT configuration file. I'm only going to be running this on the first system here on my my boot node system. All right, so it's going to take a minute to type through, but I'm going to walk through this with you here. So let's go nano Besu network slash QBFT config file.json, and this is a file that was created there. So I should be able to just paste the code in. And of course, you know, in pasting the code, let's see if I can paste the code or if I have to talk it through here. Copy. No. Looks like I've got a. Oh, let's hang on. Let's just exit. Let's exit out of that.
One eternity later.
So I'm just going to walk you through this configuration file, okay? So the Genesis section right at the top there defines what the first block of my chain is going to look like, okay? So I'm using the chain ID, which is just here, you know, 1337. That's a unique number that identifies my private network, and it's common to use, you know, LEET for private or development chains. So that is that. And let's see, I could use any number that's not already taken by a public network. You know, the fact is this is a private network, so it doesn't really matter that much right now while I'm doing testing. Now the Berlin block set to 0 just tells it to start the chain at the Berlin hard fork level. That way, you know, the chain, it doesn't need, you know, It doesn't have to evolve through all the earlier protocol versions. And Berlin is a reasonable baseline for a smart contract compatibility standpoint. Now, here where we talk QBFT right here, the block period seconds is how often it's going to create a new block. Now, 2 might be very, 2 seconds. Likely I'm going to change that to a significant amount of time just because I don't need it that much on my, every 2 seconds to create a new block is going to get a bit epic. So I might adjust that. And the epoch lengths are how many blocks are between validator set snapshots. So it's not really relevant for my proof of concept. So I'm just going to leave that at 30,000 as it sits. And the request timeouts is how long a node waits for a round of consensus before deciding the current block proposer has failed and it elects a new one. And it should be at least double the block period. Okay, so that's why I have that set to 4. Now, as far as nonce, timestamps, gas limit, difficulty, mix hash, and Coinbase, those are pretty standard Ethereum Genesis block fields. On a private network, they're mostly ceremonial. Okay, so the values are standard defaults used by Hyperledger's own documentation. So, you'd likely find those exact same ones in the documentation that you would follow or you're trying to follow. Now, the alloc section here is pre-funded accounts at the Genesis. So it's empty to start, but I'm going to fill this in later when I add my actual deploy account. Now, the blockchain section at the bottom here tells the key generator what to actually build. So it, generate true. It instructs Besu to generate a validator key, falling down, rather than, validator key pairs rather than expecting me to supply them. And it's going to generate 3. So 3 validators, which match our 3 nodes. All right. Now this will only be run once, okay? And it's used once to run the generate blockchain config command that I'm going to do in the next step. And after it's done its job, the actual chain runs from the generated Genesis JSON file, not this particular file. So this one just sets everything up and gets it to run on your validator or on your Genesis node, all right, or on that main node of your system. Right. So right now I just changed directory into the Besu network directory. And what I'm going to do is I'm going to actually run that JSON file, and we will create the network files directory with a basic structure for the 3 keys, 3 systems. So all right, config file equals qbft config file.json slash --2 equals network files. That's where it's going to, and -- private key file name is going to be equal to key. So let's run that. And you take its thing, display full help, Besu command. There we go. So that creates a network file directory, and it should have the basic structure of network files. Inside that will be the genesis.json. Then there will also be a folder called keys, and there will be 3 addresses. And inside those, there will be a key and a key.pub on there. Okay, so so what I want to do is I'm going to list the generated key directories with the 3 addresses that it actually did create here. So ls, we're gonna list Besu dash network file slash keys. Can't access it. Oh, why can't it access it? What did I do wrong? Huh. Did I spell something wrong? Okay, we were missing a required file here. This is not good. Let's try to figure this out.
One debt to society later.
Okay, figured it out. Typo. So let's try that again. Boom. There we are. Let it do its thing. And there we go. So it has generated a blockchain config. It generated 3 node keys for node 0, 1, and 2. All right, it generated QBFT extra data, and it wrote the Genesis file. So now let's do what I tried to do before, and take a look at that. So Besu network slash network files slash keys. And there we go. There are our 3 keys. So what we're going to do is we're going to write those down as node 1, node 2, and node 3, and make sure that we use the static IP address and say like node 1, and then use the static IP address, then take the actual address and put that in so that we've got those. Okay, so I'm just going to make note of that, and then we're going to move on to the next thing, and we're going to distribute the keys and the Genesis to each of the other nodes. Okay, so what I've done here now, so I made a directory called key store. Okay, and I did that on all 3 of the machines individually using their own windows. Okay, then what I did was I did this here, and I pushed it to the to 11, right, which is my second node. And then I pushed it to 12, which is my 3rd node. Okay, so the key has now been pushed to all of those. All right, so basically that copied the Genesis JSON file to nodes 2 and 3. So what I'm going to do now is I'm going to copy node 1 key to my data directory. Okay, so what I'm going to do, and just copy this. So what I'm putting in here, this is the key that I got earlier up here when we created the keys. So I need that key in here in order to get the node 1 key into its data directory. So we'll do that. Going down here. You gonna go? You gonna do it? Or what? Oh. And enter. There we are. Can't create a regular file. What? Oh, because I need to do, guess what I need to do? Give you one guess. Let's do this. Sudo Let's try that. There we are. So, of course I have to do, put that in, done. All right. Now I've got to do the same thing again. What's going on? Oh, is that what I did wrong? Oops. God, I goofed. Sorry, dudes. Sorry, everybody. Let's copy this. I goofed. Let's try this again. There. So, let's do this. Do typos. Okay, there we are. Okay, so that's the first one. And now let's do this. And the second one. There. Okay. So that should have done it. We'll check. Okay. So there we go. All right, just had some issues there where I actually didn't have the folders for it to actually put it in. So as you can see, what I did here is from my first computer into the folder, I copied the Genesis JSON into the second and third nodes. All right, so those are there and it copied the file. All right, so that is all done. So next on our list is going to be actually copying the node 1 key to its data directory, and then I'll do the same for the node 2 key and the node 3 key. Okay, got a couple permission denied things here. So the reason for that was that I didn't have the proper ownership of the actual folder on the other systems. So when I tried to push that information, it didn't. So anyways, that's what I did. And so we passed the network files, the keys here. All right, and the key pub, and it passed it there for 11 and 12. So now that is on all three of them. So now I just need to verify that the Genesis JSON file is on nodes 2 and 3. And yeah, we'll make sure that it arrived. Right, so what we've done here is we've just confirmed that the Genesis file made it to all of the other nodes. So that's where it is. So the that particular thing here just, said, Jason, give the top 5 rows of the Genesis, and it did. So that is that. So that now has created it's created a Genesis file, it's created keys, it's pushed the keys to all of the nodes, so they're all there. So I have my main Genesis node, and then I've got my 3 validators, even though one of those validators is on the first system, so it's doing dual duty. So next thing to do is going to be to open my firewall ports on all of my nodes. All right, so we needed to open 2 ports on each machine, 3303 for peer-to-peer communication between the nodes, and 8545 for the HTTP RPC interface that's used by Hardhat, as well as some other tools. So as you can see, I've just created new rules here for TCP UDP and then TCP on this. I've reloaded it and then asked for the status, and it's just showing that everything has been done. So I need to do that on the other two nodes, which I'm just going to do now. Right, so that is done on node 1, node 2, and node 3. Next step is going to be to get the boot node encode URL. So before starting the network, I need node 1's encode URL. The other nodes use this to find and connect to the boot node on startup. So I'm going to do that, and I'll show you the code that I've used for that in a moment. While I have Susie here, I'm going to show you Susie. You going to go talk to Hobbs? Yeah? Hey, Mr. Hobbs, you helping me? Susie's not being very helpful. She just wants to be in front of the camera. All right, so what I did was Besu, I got my data path here, public key, and I wanted to export the address. So what it's done is it's pulled the key pair utility and loaded the public key, and there's my public key, which I'm blurring out. And it's from the data key, which is there, which I'm also blurring out. So, so now that I have that public key, what I do is the public key format is encode : // and then your public key @ and then the IP address of your machine, which on mine is 192.168.2.10, and then 3303, which is the port that we opened up for it. So that is the format for the URL that we will be using on the other two machines. So at this point, what we're going to do is we're going to actually start the network. So I'm going to start node 1 first, and then once it's running, I'll start node 2 and then node 3. I'll find the boot node, and and it should find the boot, or they should find they should find the boot node and connect automatically. Now, this is important because each node runs in the foreground in its SSH session. So you can't close that command window while the node is running. In a later step, I'm going to set up the systemd services so nodes run in the background automatically. But for now, I'd like to keep these sessions open. Okay, so let's get going and get started on starting node 1. Where's my camera? It's there. Okay, so what I did is I got the first node up and running, and then started the second node because it was looking for, for the 3 minimum nodes, or was looking for originally 5. So we switched it to 3. So then I started the second and started the third. And now, as you can see, all 3 of them are going at the same time, doing their thing. So there we go. And it seems to be, as I said, it's registering blocks every 2 seconds. So we might need to change that because we're at block 35 already here, and it's going to keep going. But there we have that now. So I'm actually pretty happy about that. So gonna just, we'll have to, I see the block production. So what we'll have to start looking for is for healthy output, and then check the peer count via an RPC. But there we go. Okay, so what I've done here is I've just checked to see that there are, how many peer counts there are, and it got a result in a hex. So it's seeing everything, and then I wanted to see how many blocks had been written. So it's showing again a hex here, and then I did it immediately again, and I got that. And what I'm going to do is I'll do it one more time here, right? And enter, and you can see it's incremented again. So it is writing blocks for me, as you can see. So there you have it. So basically, my private blockchain is running 3 nodes, QBFT consensus, and it's producing blocks. It's the foundation of everything else that I'm going to build on this. That 2-second block is fine for now. It just means busy logs. When I set up the system D services and convert the node commands to config files, I'll bump it up to something like 5 or 10 seconds. It's quieter logs. It's easier on the hardware, especially for a lab. And I'm not doing high transaction volume. It's going to be like really, really, really short, small transactions just to prove that I can do it. Just for shits and giggles, for fun. And Bunny is really happy now. So anyways, so I'm gonna, I ran the verification check. So everything, the peer counts, everything's good. I'm gonna then set up the system, D services so that the nodes, survive a reboot without me having to manually restart them. Then I'll install Node.js and hard hat on my Windows, and I'll deploy a test contract to confirm my Windows machine can write them to the chain, which will be awesome. So there we go. So that'll be the next thing we do.
Well, you can probably tell by the shave and the change of clothes that a little bit of time has passed since I recorded that, but it's been about a week or so. I had a bunch of other stuff I had to get done. I'm going to end the video there because I'm actually working on building an interface, using Claude Code that will allow me to essentially mint an NFT, mint an asset. So I'm building out the user experience, the front end, and then we will connect the back end. So once I have a basic front end built, I'm going to create another video where, I'll wire up that front end to the private blockchain, and we will be able to see the ability to upload that picture of Calvin, right? Because I already got that photo of Calvin. We'll upload that. We'll attach a smart contract to it, and we will put it onto the blockchain and be able to see that transaction occur. So I'm not sure how long that's going to take me, but hopefully you'll, subscribe, like this video and subscribe, maybe check out some of my other stuff that I'm doing, on my car and stuff like that. And hope you enjoyed and learned something from this. And hopefully the biggest thing you learned from this is you can do it. I have no special skills when it comes to this. Really a lot of just Claude helping me, or, ChatGPT helping me to actually set this up, one step at a time. So if I can do it, anybody, well, almost anybody can do it. So anyway, thanks for sticking around to the end. Catch you later.